Hey everyone, it's Tom Cherry Holmes with the FujiNet Project, and I hope everyone is having a fantastic Sunday. I wanted to record this video to give a status report on where things are right now with refactoring the configuration program. I also wanted to give a small little status update to the fact that Moswald has been, of course, shipping out the first 50 particular units that we are sending out to early birds, testers, developers, and just overall enthusiasts who wanted to get theirs first. We ask you for one thing in return: to help us test the software, to help us find bugs, to help us make the product better. And as part of that, we really ask for a great deal of patience as we take and work through the individual bugs that are currently and as part of the software right now. And as part of this, there is an ongoing effort. I have paused all development on the end device for the foreseeable future so that I can take and work on refactoring the configuration program that comes in at boot. Why do I need to do this? Well, if we actually take a look at FujiNet config right now as things stand, we'll see a number of things that really could use some serious improvement. If we look, we can see right here that we have on the left-hand side the master branch, which is currently the version of config that is built and is packaged whenever we build a new version of the software. I have taken and broken off onto a new branch called Refactor. So if you want to follow along with what's happening with the Refactor, you can take and check out the Refactor branch. And you can see right now that it's currently 41 commits ahead of master. It's going to be a whole lot more by the time I'm done. So what am I actually doing here? In order to explain that, we have to take a little bit of a deep dive through the code. You can see the configuration program, and the configuration program is broken up into a couple of major sections. The first is config, which actually deals with setting the network parameters, as well as reconnecting back to the network whenever config first boots. Apologies, you can hear my daughter upstairs thumping on the stairs. Okay. So the config section dealing with network configuration. We have Diskulator, which deals with the mounting of disks, the unmounting of disks images, creation of disk images, and basically just selecting and unselecting disk images to mount into various device slots from various host slots. There is the info section, which shows the current adapter configuration. And there are various other functions for utility functions, for handling screen output, for killing the program, bits and pieces to handle the bar that is used, made out of player missile graphics, to all across the program for selecting individual items, and so on. The first major difference that we actually see is that Diskulator is being broken out into individual sections for each of the major components in which you go through. You have host, which deals with selecting a particular hosted device slot. You have select, which allows you to select a disk image from that device slot. You have drive, which allows you to take and then assign what you have selected with Diskulator select into a particular device slot. And as we go through the individual sections, a few things will become apparent. We start by looking at Diskulator.c. And one of the first things that you'll notice with Diskulator.c as it stands in production, as it were, there's a great deal of global variables. Now, this is understandable because we are writing this in CC65, and there isn't really a stack on a 6502. The stack has to be simulated, so the usage of local variables becomes can become somewhat inefficient. The downside to this is that you're having to take and allocate all these fixed locations in memory, and the variables are now disconnected from the functions and can potentially be used in unexpected ways as you traverse from function to function, as things might get reused from memory constraints, that sort of thing. It invites a great deal of pacification, which needs to be dealt with. Another thing that you'll notice that the individual data structures, which make up things like the host slots, the device slots, the structure used for creating a new disk image and the like, all of that is also placed in global space and explicitly defined, which makes it much more difficult to deal with as we take and try to break all these things up into individual functions. You'll also find a mixture of user interface functions and functions for talking with the FujiNet to do things like ferry changed host slots back and forth between the Atari and the FujiNet itself, the setting of device slots, mounting of device slots, unmounting of device slots, creation of new disk images, etc. And all of these things are depending on these global variables that are created. Now, some of these we do have to preserve because it's easier to deal with. Some of these structures are large and therefore unwieldy to keep on a virtual stack. So we need to keep some of these as globals, such as host slots, device slots, etc. But a number of these various variables, these integers, these shorts, can all essentially be migrated into local stack to make the code much easier to read by keeping the variables and where they are used within close visual proximity. You'll see in contrast, first thing you'll notice is that host slots and device slots are now defined in terms of a particular custom type definition. And these are actually defined here in Fuji type defs. We've now moved all of the complex data structures into their own file and defined them as type defs so that we can easily reference them, both in terms of global state and in terms of passing these individual structures to and from other parts of the program as pointers. We're also starting to use enumerations for various different things. Currently, this is, for example, possible FujiNet error messages that are fatal and will cause a stop of the program. Keeping these out so that we can keep these things more readable, so on. All of this has been moved into its own file. And it has the consequence of making it much easier to read and to deal with. You'll see here the usage of our device slots global enumeration here, as well as the error here. You can see what error this is and the consequence of that error. Much easier to read. And you'll also see the individual UI operations have been moved to their own functions and called as needed to make the overall flow of the program a lot easier to understand. The setting up of the display lists, common elements of screens, all of this systematically taken and pulled out. Of special note, especially in the host section, because we have keys that are common to both host slots and device slots that were being duplicated all across the program. This is for host slots, and you have another one for device slots. Much the same bits and pieces of code being duplicated in two different sections here. All of this has been refactored into a single function. And you'll notice the judicious use of pointers to indicate the current entry being used. This basically allows for one function to handle both the device slots and the host slots with equal ease. And you'll find that all of the individual chunks of code that we just explicitly put into each of the case statements have been moved into their own functions. Much easier to read. It's clear as to the consequence of each of these individual switch actions. What will be taken? We also see partially here usage of enumeration to set program states, making it much easier to take and fall back through to the top level parts of the system, to the top level parts of the code, and to easily and effortlessly switch between state without having to take and jump through hoops with goto like we were doing over here. You can see lots of goto commands and labels for goto commands, and so on, which was really making this code very hard to follow. This is being done for each of the major sections, where the process literally is to take the individual chunks of code, break them into their separate files, fix the errors that happen, then fix the changes in logic that need for those things to happen, fixing the resulting syntax errors and compiler errors that result from those process, and repeating until each of these individual sections function completely autonomously on their own and are verified to function entirely autonomously on their own, at which point they can be combined back together into the completed program. The end result being, of course, that in comparison to Disculator basically being a massive pile of code over here on the left-hand side, we now have the only thing that Disculator has is common bits and pieces used by all the different modules, and the entirety of the Disculator state machine collapsed into a well-defined code path that we can easily take and elegantly move in and out of. Each of these comprising their own little state machines to move between different program states, with the definitive program state being easily defined over here. The other major thing to note, and the final thing I'll actually take and point out here, is that we're not only using judicious use of pointers for things like entries, so that we can easily take and change those things within different contexts, but we are also taking and breaking out the formerly global aspects, the former global variables for things like path, and trying to pass those things into only the functions that need them, so that we're not constantly having to tangle around file name transformation functions and having to take and just do all sorts of weird little workarounds that we were doing before. The end result is that the code is a lot simpler, a lot easier to read, and it's not all glommed together. There's still a lot to be done, but you can see right now this is essentially what I'm in the middle of. As to how long this will take, I am already 2 days into this, and I expect to be working on this for at least the next week as I take and carefully take and break this code into pieces, fix the broken pieces, combine them back together into modules, into workable modules, and then working out the logic errors that result from the connection of those modules. So I'll go ahead and leave you guys now with that. I just wanted to go ahead and keep you guys up to date with what I was doing. And if any of you guys want to help out, please feel free to contact me in any way that you possibly can. We could use all the help we can get, but I wanted you guys to see where we are at this particular point in time. So until next time, guys, have fun.